so I'm going to do section 3.2, and if you had intermediate algebra recently, especially if you took me for intermediate algebra, you'll recognize a lot of these problems as well. Almost this entire section is just something I copy and pasted from some intermediate algebra homework assignments that I gave. So hopefully this starts to feel like review. The very end of this section is new, and it's new. That's going to be important if you take brief calculus or regular calculus. So it's a you don't want to cheat yourself at the. You want to make sure you go all the way through the end of this video. So the first few problems, they give me function definitions. Problems 1 through 18. I define a k, a f, a g, and an h function, and then I ask you in each problem to work just with one of the functions. Problem 2 says to work with the f function. And very specifically, it says to work with the f function, but change the x in that function to -2 and simplify. It's just an order of operations problem. I went to the f function. I replaced the x with -2. I do orders of operations. The first thing I do is a multiplication of 3 times -2, and then I add the -6 and 4 and get -2. The answer I'm going to write for this, I'm going to write f of -2 equals -2. So this is just to get you warmed up with working with function notation again, just in case you hadn't worked with it in a while. Problem 4 wants me to work with the g function, and it wants me to change the x with 0 and just do the orders of operations necessary to simplify. So there were two x's. I put 0 in for both of them. 0 squared is 0 times 0, which is 0. 5 times 0 is also 0. So the algebra gives me 0 plus 0 plus 6, which is just 6. The answer, I could just write 6. Usually for these style of problems, I write the problem along with the answer. So I'm going to write g of 0 equals to 6. But if you wrote just the number 6 for part number 4, or just the number -2 for number 2, that would be okay. So I'm going to do all the even problems. Some of the problems have me put letters in. When I put letters in, that letter will be in my answer. And for each of the problems, I copied the function that I needed. So in problem 6, I need the function h. H is the only really tricky function. To do number 6, I go to the h function, and any place there's an x, I put a 3. I guess you could think of h like this. You can think of this as h of x equals 0x plus 4. If you really need to see an x, you can write a 0x, because 0x is the same as 0. 0x plus 4 is the same as 4. And this I could go 0 times 3 plus 4, which is 0 plus 4, which is 4. There's just no place to plug the x. All the h functions, anytime I call it out, the answer is going to be 4, because there's no place to plug that number. If you wanted to insert a place to plug the number by inserting a 0x, it's still going to 0 out. Every single problem in this grouping from 1 to 18 that calls out the h function is going to have an answer of 4, because there's going to be no place to plug the number or the letter. The right-hand side is going to remain unchanged because there's no place to plug the thing that's in the parentheses. For problem 8, I call out the k function, which I just copied and pasted so I didn't have to go searching for it. And I'm going to write 2 over -6 plus 3 equals the k of -6. Notice I didn't put the -6 in a parentheses. It wouldn't be wrong to have it in a parentheses, but because this x doesn't have a multiplication, negative, or an exponent, I didn't need to put it in a parentheses when I did the substitution. Now I'm going to simplify the denominator. -6 plus 3 is -3. This is what k of -6 equals to. I'm going to leave the answer as a fraction. It looks odd to have the negative in the denominator, so I'll tuck it up and move it to the numerator. But if your answer, if you had 2 over -3, or if you move the negative to the front of the fraction and wrote -2, comma 2/3, that would be okay. As long as I see the fraction 2/3 along with a negative sign somewhere, your answer is going to be correct. For me, having the negative in the numerator just looks the most normal, and so I did that. I moved it up. If you just have an integer over an integer, the negative sign can be moved around. So I'm going through these kind of quickly. Hopefully it's not too quick for you. For 10, I called out the f function. Again, I cut and pasted the f function so I could have it ready for me. I'm just going to change the x to a c and stop. This is actually the whole answer. If you did this, this would be a wrong thing to do, and you're going to lose points. So when there's a letter in the parentheses, if you take the expression and you set it equal to 0 and write an answer like that, if you wrote c equal to -4/3 for this, that would be wrong. All this is asking me to do is change the x to the letter c and stop. I don't set it equal to 0. So I'll cross it out because it's not the right thing to do. Similarly, for problem 12, I'm going to change the x to the letters b minus 2. In this case, I need to use a parenthesis, so I'm putting more than just one thing in for the x. Writing the c in a parenthesis wasn't necessary because 3 and then parentheses c would still mean 3 times c. For this problem, I'm going to need to do some algebra to simplify it, but I'm not going to set it equal to 0. What I'm going to do is simplify by multiplying the 3 by b and getting 3b, and the 3 by -2 and getting -6. And then I'm going to combine the like terms of -6 and 4, and those combine to a -2. For my answer, I'm going to write f of b minus 2 equals 3b minus 2. And again, it would be wrong if you took that 3b minus 2 and set it equal to 0, if you added 2 to both sides and got 3b equal to 2 and divided by 3 and got b equal to 2/3. If you wrote b equal to 2/3, if this was a test question, it'd be a -2, but it's the wrong thing to do. This is just asking me to replace the x with b minus 2 and simplify. It does not ask me to set it equal to 0. It didn't say anything about finding intercepts. And then when you set something equal to 0, that's generally what you're doing, is finding an intercept. So that would be not something that's appropriate to do here. The answer for this problem 12 is just 3b minus 2. 14 wants me to take the x's in the g function, which I wrote above it, so I didn't have to go searching for it. So I take the g function and I change each of the x's to 3a, and I'm going to simplify. I'm going to factor just so I get practice factoring. If my answer has a square and that's something that can be factored, then I'm going to factor. The 3a square part means 3a times 3a, which is 9a squared. The 5 times 3a is going to be 15a, and the 6 is just a 6. So first of all, something that has a square, I'm going to factor unless it started factored and I got rid of the factoring. And the first step in factoring is any time is to pull out a common factor. Each of the numbers here have a common factor of a 3 that I could factor out. So I've factored out a 3. And now I'm going to try to factor off to the side. I'm going to try to factor 3a squared plus 5a plus 2 using bottoms up, which means I'm going to multiply the 3 and the 2 and get a squared plus 5a plus 6. I'm going to factor this into a plus 2 times a plus 3. I started off multiplying by 3 in my bottoms up. I'm going to divide by 3. For this first, the fraction doesn't reduce, so I bring the bottoms up and get a 3a plus 2. And then the next one, the fraction does reduce. So this was super fast. This is not intended really even to be something that you could follow that easily. But if you are stuck with factoring and you don't know how to factor, this is a strategy that will lead to a factoring that's successful. So for my answer for problem 14, I should say g of 3a equals 3, and then I need two parentheses. One parenthesis has an a plus 1, another parenthesis has a 3a plus 2. So this is a college algebra class, not a beginning or intermediate algebra class. I shouldn't even show this at all. I should just say, okay, this needs to be factored, and you should be able to go from there to there without me holding your hand. At some point, you just have to be able to do that, especially if you're going to Math 212 or 220 in your future. There's no way your teacher will have time to show or explain factoring. So at some point, I'm just going to factor in my head. And if you can't factor, you need to come visit me, and I'll show you how to do the factoring but maybe for the rest of this lecture I won't show any factoring. I'll just go from the problem to the factored answer if it needs to be factored. In 16, I'm going to go to the g function, which I wrote up again because I knew I was going to need it and I didn't want to have to flip back pages. I'm going to change each of the x's to an x plus 1. I'm going to put that x plus 1 in a parentheses. So g of x plus 1 I get by taking those two x's in the g function and replacing them with an x plus 1. The first x plus 1 quantity squared is a foiling problem. So when I go to simplify this, the x plus 1 quantity squared I need to FOIL. The firsts are x times x, which is an x squared. The outers are an x times 1, which is a positive 1x. The inners are a 1 times x, which is another positive 1x. The last are 1 times 1, which is a 1. So the x plus 1 quantity squared FOILs out to be x squared plus 1x plus 1x plus 1. That clears the first parentheses. The second parentheses, I need to multiply 5 times x and 5 times 1. When I multiply 5 times x, I get plus 5x. When I multiply 5 times 1, I get plus 5. And then I have a plus 6. Now I'm going to combine like terms. The x squared remains alone. But this plus 1x, this plus 1x, and that plus 5x all can be combined together. They're all pluses. 1 plus 1 plus 5 is 7. So I'm going to get a plus 7x. And this 1, that 5, and that 6 add up to be 12. So I get g of x plus 1 is x squared plus 7x plus 12. I can factor that because it has a square and it can be factored. I should factor it just to get in practice. So next to the problem, I'm going to write what that factors into, and I don't have room. That factors into x plus 3 times x plus 4, or x plus 4 times x plus 3. So I don't need to write the problem next to the answer, but it's nice too. So I'm going to say g of x plus 1 is x plus 3 times x plus 4 because that's what that factors into. For 18, I'm going to replace the x with a minus 2. I didn't put the a minus 2 in a parentheses because the x doesn't have an exponent, a negative, or a multiplication, so it doesn't really need to be in parentheses. I'm going to combine like terms in the denominator. That negative 2 plus 3 combined to be a positive 1. The numerator stays 2. The denominator simplifies to be a plus 1. That is not reducible. I'm not going to set the denominator equal to 0 and find the domain of this because I wasn't asked to find the domain. I was just asked to change the x to a minus 2 and simplify, and that's all I'm going to do. I'm going to change the x to a minus 2. I'm going to simplify and stop. My answer is going to be 2 over a plus 1, and that's all there is to do for problem 18. Problem 20 wants me to subtract the two functions and leave the letter x. So the instructions that say find g minus f of x, that just means to subtract the right side of the g function minus the right side of the f function and leave the letter x. This x in parentheses looks like it means to multiply by x. A lot of times my D/F students will do that, but rarely will my A/B students, which are going to be most of you. I would guess there's 30 students in this class. I will be disappointed if I don't give 22 A's and B's, so most of you won't make this mistake. Most of you might remember how to do this already. To find g minus f of x, what I'm going to do is write an equal sign, minus sign between two parentheses. In the first parentheses, I'm going to put the right half of the g function because the g is written first, which is 2x squared plus 5x plus 3. After the minus sign, I put another parentheses, and inside it, I'm going to write the right side of the f function, which is 2x plus 3. The algebra is just going to be to simplify this. The first parentheses I wrote really weren't necessary, and I'm just going to drop them. The second parentheses was necessary. The negative needs attached to the 2x and to the 3, and when I drop that parentheses, I get a minus 2x and a minus 3. I'm going to combine like terms. The like terms are a 5x and a minus 2x. and a positive 3 and a minus 3. The 2x squared I'm going to bring down. The 5x minus 2x I'm going to write as a positive 3x, and the 3 is going to cancel. There's a square, so there's a chance that it might factor, and it does. When I go to write my answer, I'm going to write the problem down, and next to it I'm going to write what this factors into. Hopefully you can pause the video and factor that without me factoring it for you. That would be a good thing. It factors because there's a common factor. On either side of the plus sign there's an x, so the factoring is common factor factoring. I'm going to factor out an x. From the 2x squared, when I take one of the x's away, I'm left with a 2x. From the plus 3x, when I take an x away, I'm just left with a 3. So that factors into x times 2x plus 3. And the answer to problem 20, g minus f of x, is going to be x times 2x plus 3. 22 wants me to multiply each function. That little dot between the g and the f means to multiply. To do this, I'm going to write two parentheses. I could put a times sign between the two parentheses. I don't need the times sign. If I write two parentheses next to each other, that means times anyways. In the first parentheses, I'm going to put the right side of the g function, which is 2x squared plus 5x plus 3. And in the second parentheses, I'm going to put 2x plus 3. This is one of the rare times that my answer is going to have an exponent that I'm not going to factor my answer. This is factored, and if I wanted a factored answer, I wouldn't multiply this out. But because it asks me to multiply out, I'm not going to multiply and refactor because I'll just get to what I started. The multiplying is a mess, though. For the multiplying, I need to take the 2x squared, multiply it by both the 2x and the 3 in the right parentheses. So I need to do that. I also need to take the 5x in the parentheses and multiply it by the 2x and by the 3. And I need to take the 3 in the first parentheses and multiply it by the 2x and by the 3. So there's tons of multiplication to do the multiplication that's asked of me here. The 2x squared, I multiply by the 2x and the 3, the 5x by the 2x, the 3 and the 2x and the 3. So I wrote down all the multiplications I need to do. The first multiplication, 2x squared times 2x, I multiply the 2's together and get 4. X squared times x is 2x's times 1x gives me 3x's, which is an x cubed. Next multiplication is 2x squared times 3. They're both positive, so I put a plus sign. I'm going to multiply the 3 and the 2 and get a 6 and leave the x squared alone. Next multiplication, 5x times 2x, they're both plus, so I put a plus sign. I multiply the 5 and the 2 and get a 10. I multiply the x and the x and get x squared. Third multiplication, both positive, so I get a plus sign. The multiplication I do is the 5 times the 3 and get a 15, and I leave the x. Second to last multiplication, they're both plus, so I get a plus sign. I multiply the 3 and the 2 and get 6 and leave the x alone. Last multiplication, 3 times 3, I get 9. So that's all the multiplying that needs to be done to do g times f. And now I'm going to combine like terms. I'm going to combine the 6x squared and the 10x squared. I'm going to combine the 15x and the 6x. And I'm going to stop. So I'm going to write g times f of x, which is the problem, equals 2. I'm going to bring down the 4x cubed. When you're adding, the exponents don't change. I'm going to write this as a plus 16x squared. I'm going to write that as a plus 21x. I'm going to bring down the plus 9, and I'm not going to factor this. First of all, I don't really factor with cubes well, which would make this hard to factor. Second of all, because the problem started factored, I must not want a factored answer. It asked me to multiply it out, and I multiplied it out. To actually factor it, this would factor into that, which could actually factor more. But to go from this to that, factoring would be something that's beyond what we can do right now. A little bit later in the semester, when we learn synthetic division, we'll have a structure for factoring this. So because the problem started factored and I unfactored it, I'm not going to refactor it. In the other problems that I got exponents in my answer, they didn't start factored and I wanted to factor them. 24, composition of functions. This circle doesn't, that open circle doesn't mean multiply. This means find f of g of x for what that's worth. This symbol right there tells me to do a new composition, a new function, which is composition of functions, and it means to put the right function into the left function. To do f composed with g of x, to do this, I do this. I write the f function without the x. I leave a parentheses where the x was. I'm going to insert the right side of the g function inside the parentheses and simplify. So composition is strange. Hopefully you haven't completely forgot it. So to do f composed with g of x, I'm going to follow my steps perfectly. I write the f function, which is 2x plus 3, without the x. So this was the first thing I said I was going to do. I took the f function, 2x plus 3, I wrote it without an x, and I did my second step. I left a parentheses where the x was. So in one line, I'm able to do all three steps, which is maybe not the best, but it is what it is. So I've done the first two steps. I wrote the f function, 2x plus 3, without the x. I left a parentheses where the x was. Now I'm going to insert the right side of the g function inside the parentheses, which is 2x squared plus 5x plus 3. So that's the third step, and I'm going to simplify. To simplify, I'm going to clear this parentheses. I'm going to multiply 2 times 2x squared and get 4x squared. I'm going to multiply 2 times 5x and get 10x. I'm going to multiply 2 times 3 and get 6. I have the plus 3 that I haven't dealt with. The simplify is going to be combining like terms. I'm going to add the 6 and the 3 and get a 9. And if that factors, I would factor 4x squared plus 10x plus 9, 36, 218, 6 and 6. That's prime. So my answer, because that doesn't factor, is going to be that in its unfactored form because that's prime. I'm going to write the problem, f composed with g of x, and to the right of it, I'm going to write what it equals. It equals 4x squared plus 10x plus 9, and that's prime, so I'm not going to factor it. So I bet you I have g composed with f coming up next, but I don't. I just have a nice plus, so no more composition here. To do g plus f of x, I can write two parentheses separated by a plus sign. It turns out that neither of the parentheses is really necessary. In the first parentheses, I write the right side of the g function, which is 2x squared plus 5x plus 3. In the right parentheses, I write the right side of the f function, which is 2x plus 3. And now I'm going to simplify. The parentheses that I put in were really a waste of time. I could drop both of them without changing the contents of the parentheses. And now I'm going to combine like terms. I'm going to combine a 5x and a 2x and a 3 and a 3. I'm going to leave the 2x squared alone. 5x plus 2x is 7x. 3 plus 3 is 6. That does factor, so I should factor it. I'll factor it off to the side just in case you can't factor that. So my efforts to factor 2x squared plus 7x plus 6, I'll use bottoms up. I'm going to multiply the 2 and the 6. Rewrite this as x squared plus 7x plus 12. That factors into x plus 3 times x plus 4. Finish the bottoms up. I started off multiplying by 2. I'm going to divide by 2. First fraction doesn't reduce, so I bottoms up and make it a 2x plus 3. Second fraction does reduce. I'll make that an x plus 2. My answer, I'm going to write the problem next to the answer. Because the answer had an exponent in it, and it wasn't something that started factored, I should write a factored answer. My answer is going to have two components. One's going to be a 2x plus 3. The other's going to be an x plus 2. It doesn't matter which one I write first or which one I write second. I could write x plus 2 times 2x plus 3. What would be wrong if you did this, if you want 2x plus 3 times x plus 2 and set it equal to 0, and then went 2x plus 3 equal to 0, x plus 2 equal to 0. Solving this, you'd get x equal to negative 3 halves. Solving that, you get x equal to negative 2. If you wrote negative 3 halves and negative 2 down, that's wrong. For none of these problems am I setting the answer equal to 0. When you're setting the answer equal to 0, you're getting x-intercepts, but because the instructions didn't say anything about finding x-intercepts, that's what you get when you set the function equal to 0, that's the complete wrong thing to do. 28 wants me to do another plus, and it wants me to do this f function, which is 2x squared minus 5x minus 3, plus this f function, g function, which is x minus 3. They're new functions, are new right-hand sides to the old function names. To do this, I wrote two parentheses separated by a plus sign. The parentheses really weren't necessary, so if you didn't put them in, that wouldn't be wrong. Dropping the parentheses and combining like terms. The like terms that need to be combined are minus 5x and a plus 1x. That x that doesn't have a number has an implied 1. Those combine to be a minus 4x. And the other like terms are the minus 3 and the minus 3. Both those 3's have the same sign, so I'm going to add them and keep them negative. So this combines to 2x squared, which just drops down and doesn't change, minus 4x minus 6. Because there's a square and the initial problem doesn't start factored, I should try to factor it. I'm going to pull out a factor of a 2 and get x squared minus 2x minus 3, and that factors more. My final answer is going to be factored. The common factor of 2 is going to be in my final answer, and this x squared minus 2x plus 3 factors into x plus 1 times x minus 3. Notice that's a real, hopefully easy factoring, so I'm not taking the time to factor that. If you don't know how to factor this, and this step is a big step for you, then come visit me or visit one of our tutors to have them help you remember how to factor that, because that's a skill that you have to have at some point that I just can't keep redoing in the videos. Otherwise, the videos get more obscenely long than they are. They're already hour and a half, and then if I started showing every detail, they might get to be 2.5 hours, which really would probably drive you crazy. 30 asks me to form a fraction. It wants f in the numerator and g in the denominator, so this slash means a fraction. And the only hopes of reducing a fraction is if you can factor and cancel. So the only way 30 is going to reduce is if I can factor and cancel. I may have factored this already, but I'm going to just do it because this is bottoms up factoring. I'm going to do it off to the side. I'm going to factor that numerator. I'm going to multiply the 2 and the 3 and get x squared minus 5x minus 6. That factors into x plus 1 times x minus 6. I started off multiplying by 2. I'm going to divide by 2. First fraction doesn't reduce, so I bottoms up and get 2x plus 1. Second fraction reduces to 3. So into my numerator, I'm going to change the 2x squared minus 5x minus 3 into what it factors into, which is 2x plus 1 times x minus 3. The step of factoring doesn't change the denominator, but it sets me up to cancel now. Because the numerator is factored and it cancels with the denominator, there's an identical copy of the denominator in one of the factors, I can cancel the denominator. I'm ready to write my answer. I'm going to write the problem next to the answer. And what's left after I cancel is no longer a fraction. So I'm not going to write a fraction anymore because I've canceled the entire denominator. What's left in the numerator is just the 2x plus 1. It doesn't need to be left in a parentheses anymore. The only reason it wasn't in a parentheses is just because of the factoring. Because I've canceled out the factoring, my answer doesn't need the parentheses anymore. I might need this again, that this 2x squared minus 5x minus 3 factors into 2x plus 1 times x minus 3. And I think I'm going to need that right away. I'm going to need it in 32. 32 is the reciprocal of the last problem. This asks me to form a fraction. The division sign there we do by forming a fraction. I'm going to put the right side of g in the numerator because it's written first, the right side of f in the denominator because it's written second. And now I'm going to reduce. The reducing for fractions is factoring and canceling. I know how to factor this 2x squared minus 5x minus 3 because I just factored it. That factors into 2x plus 1 times x minus 3. So 32 is just like 30 in that it's asking me to form a fraction. The difference is what goes in the numerator and the denominator. And when I cancel, just like I did in the last problem, my answer is still a fraction. So when I canceled in 30, I canceled the entire denominator, and my answer wasn't a fraction. I didn't need to show a 1 for the denominator. But in 32, because I canceled the entire numerator, I can't write a fraction without a numerator. I've canceled the entire numerator, so I leave a 1 behind. My answer in 32 is still a fraction. It's going to have a 1 in the numerator. I don't need the parentheses in the denominator anymore because the reason for the parentheses was the factoring. I took the factoring away, so I don't need the parentheses anymore. So the difference between 30 and 32, which both basically ask the same question, is how my answer is written. In 32, I've canceled out the entire denominator. My answer wasn't a fraction. But in 30, I canceled out the numerator. I can't write a fraction without a numerator, so I left a 1 behind. Finally, another composition. And not such a bad composition either. 34, to do g composed with f of x, which is the same as g of f of x. I'm going to do this in 3 steps, but show them in once. First thing I do is I write the right side of the g function, because the g is written first, without the x. I'm going to leave a parentheses where the x was, and then I'm going to insert the right side of the f function inside the parentheses and simplify. So it's 3 steps, but you won't see the 3 steps because I can do them all in one big line. So g composed with f of x equals, because the g is written first, I write the right side of g without the x. I leave a parentheses where the x was. So this is the first and the second step, is writing the right side of the g function without the x. I left a parentheses where the x. The third step is to insert the right side of the f functions inside the parentheses, which is 2x squared minus 5x minus 3. And now I'm going to simplify. The parentheses in this case wasn't really necessary. If I didn't write it, it wouldn't matter because I can drop the parentheses without doing any changing. I'm going to combine the 3's at the end. Those are both negative, so they're not going to cancel to 0. They're going to combine to be a minus 6x, or minus 6, should I say. And 2 times 6 is 12. There's no factors of 12. 6 and 2, 12 and 1, 3 and 4. This is prime. Because this is prime, I don't need to factor it. If you attempted to factor it, you'd find out that it wouldn't factor. And because it can't factor, I won't factor it. I won't set it equal to 0. I'll just write the problem next to the answer and say g composed with f of x is 2x squared minus 5x minus 6. (36) wants me to do a subtraction. I'm going to write an equal sign, 2 parentheses separated by a minus because the minus between. I'm going to write the right side of the f function first, which is 2x squared minus 5x minus 3. Then the right side of the g function second, which is x minus 3. I'm going to simplify. First parentheses I can drop without doing any changing. I can leave it at 2x squared minus 5x minus 3. The second parentheses, the minus in front of it, is going to change the sign in front of the x and put a minus in front of it. Change that sign in front of the 3 to a plus. Now I'm going to combine like terms. The like terms are going to be the minus 5x and the minus x. That minus x I can think of as a minus 1x. And then the minus 3 and the plus 3. So I look for like terms. The 2x squared is going to remain 2x squared. The minus 5x and minus 1x, because both the numbers in front of the x's are negative, I'm going to add those and keep them negative and get a minus 6x. And the minus 3 plus 3 are going to cancel. Ready to write my answer. My answer is going to be how that factors. I'm going to write the problem down, and then next to the problem, I'm going to factor that. This is a square, so there's a potential for it to factor. There's just a common factor factoring here. There's an x on either side of the minus sign, and both numbers are divisible by 2. So I'm going to factor out a 2x. When I factor out a 2x from the 2x squared, I'm just left with an x. I took the 2 away in one of the 2x's. I'll leave the minus sign. When I factor the x away from the 2 away from the 6, I'm left with a 3 because 6 divided by 2 is 3, and I factored out the x. So for the best answer for problem 36 is 2x times x minus 3. 38 finally doesn't have an x in the parentheses. For the next few problems between 37 and 48, there's new functions, and I'm asked to plug numbers in. For each of the problems between 37 and 48, I'm going to pretend the problem had an x in it, but I'm not going to do too much simplifying. So if problem 38 said h times k of x, I would write 2 parentheses, nothing in between them, because writing 2 parentheses next to each other indicates times. If the problem said h times k of x, in the first parentheses, I'd write the right half of the h function, which is x squared plus 2x plus 1. Second parentheses, inside of it, I'd write a 2x minus 5. To answer this problem, I need to change the x in the problem that I just wrote to a negative 1. My answer is going to be a number. For every number between 37 and 48, I'm going to pretend the problem had an x, write an unsimplified version of the problem with the x, and then change the x to the number in the parentheses and simplify. It's a lot easier to simplify when I change the x to a number than it is simplifying with the x's. And I'm asked to change the x to a number, so I'm going to do that first. So h times k of negative 1 can be found by finding h times k of x and then changing each of the x's to a negative 1. First thing I'm going to do after I put the negative 1 in for the x is negative 1 quantity squared, which is negative 1 times negative 1, which is plus 1. And then 2 times negative 1 is negative 2, and this plus 1 is a plus 1. In the left parentheses, 2 times negative 1 is negative 2, and I'm going to leave the negative 5. Now I'm going to combine like terms, or simplify each parentheses down to a single number. First parentheses, 1 minus 2 plus 1 comes out to be 0. Second parentheses, the numbers 2 and 5 have the same signs. I add them and keep them negative. I get 0 times negative 7. I'm ready to write my answer. I'm going to write the problem, h times k of negative 1, next to the answer. The answer is what those two numbers multiply out to be, which is 0. Doesn't mean no solution. It's okay to have 0 for an answer. 0 is not no solution. So for each of the problems between 37 and 48, I'm going to pretend the problem had an x, write what I'd write down for my first step if the problem had an x, and then I'm going to change the x to the numbers in the parentheses. My answer is going to be what I get when I simplify. So if problem 40, which wants me to find k minus h of 0, said k minus h of x, what I would do is write 2 parentheses separated by a minus sign. In the first parentheses, I'd write the right side of the k function, which is 2x minus 5. In the second parentheses, I'd write the right side of the h function, which is x squared plus 2x plus 1. Not going to simplify that because I'm allowed to plug 0 in for x, and it's going to be a lot easier to simplify when I change the x to 0, so I'm going to wait to simplify. Until I do that transformation of x to 0. Now I'm going to work on getting each parentheses down to a single number. In the first parentheses, I have multiplication to do, which is 2 times 0, and 2 times 0 is 0. In the second parentheses, I have to do 0 squared, which is 0. I have to do 2 times 0, which is 0. Now I'm ready to get each parentheses down to a single number. The first parentheses comes out to be a -5 when I get it down to a single number. The second parentheses comes out to be a +1. And I don't need the plus sign in front of that one. So I'm just going to write -5 minus 1 without writing the plus sign in front of that one, because the second parentheses just simplifies to a +1 or a 1. And I just drop the 1, leaves me with -5 minus 1. Both those numbers have minus signs in front of them, so I'm going to add the numbers and keep them negative. My answer to problem 40 is going to be -6. 42 wants me to multiply the functions and then plug in 4. The nice thing is I don't have to multiply with the x's, which is a nuisance. If the problem had an x instead of a 4, if it said k times h of x, I'd first write the right side, 2 parentheses, with no sign between for the multiplication. In the first parentheses, I'd write the right side of the k function, which is 2x minus 5. In the second parentheses, I'd write the right side of the k function, which is x squared plus 2x plus 1. I could simplify that and then plug 4 in, but it's going to be a lot easier to plug 4 in and then simplify. And because this problem wants me to change the x to 4, I'm going to do that. So this gives me 2 times 4 minus 5 times 4 squared plus 2 times 4 plus 1. The 2 times 4, I'm going to change to 8. I'm going to leave the minus 5. The 4 squared, I'm going to write as 16. The 2 times 4, I'm going to leave as an 8 with the plus sign between and the plus 1. First parentheses comes out to 3. Second parentheses comes out to be 25. When I multiply 3 times 25, I get 75, which is going to be my answer. I don't really need to write the problem next to the answer, but I like doing that. So my answer, I'm going to write k times h of 4 is 75. 44 wants me to do h composed with k of 0. First thing I need to do is h composed with k of x. To do h composed with k of x, I write the h function, x squared plus 2x plus 1, without the x's. So because the h is written first in its composition, I write the function h, which is written first, without the x's. I leave a parentheses where the x's were. Inside the parentheses, I write the right side of the k function, which is a function that's written second. So h composed with k of x, which isn't what I have to simplify, is 2x minus 5 quantity squared plus 2 times 2x minus 5 plus 1. I could simplify that and then plug 0 in, but it's a lot easier to plug 0 in and then simplify. So that's what I'm going to do, because that's what I'm ultimately have to do, is change the x to 0. And now I'm going to simplify. In the first parentheses, 2 times 0 is 0. Similarly, in the second parentheses, 2 times 0 is 0. Each parentheses comes out to be a -5, because 0 minus 5 is -5. So I get -5 quantity squared plus 2 times -5 plus 1. -5 squared means -5 times -5, which is positive 25. For the next place, I can write plus -10, or I can write just -10. It's easier to write just -10. And the plus 1 hangs around, and that simplifies to be 16. So for my answer, I'm going to write h composed with k of 0, which is the problem, equals to the number 16. If you just wrote the number 16, that would be adequate, but it's probably desirable to write the problem with the answer. 46 wants me to do h composed with k of -2, even though I just did h composed with k of x. I'll do it again. H composed with k of x I get by writing the h function, which is x squared plus 2x plus 1. I write it without the x, leave a parentheses where the x's were, put the right side of the k function inside the parentheses. If I didn't have this negative 2 to work with, I'd have to simplify that. But because I have the negative 2 in the parentheses, I'm going to change the x's to a negative 2, and then I'll simplify. First parentheses, I go 2 times negative 2, and 2 times negative 2 is negative 4. Similarly, in the second parentheses, I go 2 times negative 2 and get a negative 4. Both parentheses are the same. Both parentheses, the numbers are both negative. I'm going to add those and keep them negative. Both parentheses come out to a negative 9. Negative 9 quantity squared is negative 9 times negative 9, which is 81. 2 times negative 9 is negative 18. I think that comes out to 64. Assuming I didn't make a math error because I was too lazy to pull out my calculator. So things simplifies to 64. So that would be my answer. 64 is the answer. I like writing the problem next to the answer, but it's not a deal breaker if you don't. 48's reverse, k composed with h of negative 6. To do that, I'm going to find k composed with h of x. To do k composed with h of x, because the k is written first, I write the k function, 2x minus 5 without the x. Leave a parentheses where the x was. Inside the parentheses, I put the right side of the h function, which is x squared plus 2x plus 1. I could simplify that if I wanted to, but I don't have to simplify with the x's because in this problem, I'm allowed to change the x's to negative 6. It's easier for me to simplify with negative 6 than it is x, so I'll do that. I change the x's to negative 6, and now I'm going to work on simplifying. Negative 6 squared is negative 6 times negative 6, which is 36. 2 times negative 6 is going to give me the luxury of writing a minus 12 there. I bring down the plus 1, and I still have the minus 5. Inside the parentheses, I can get that down to one number. 36 minus 12 is 24, plus 1 is 25. Now I do the multiplication. 2 times 25 is 50. 50 minus 5 is 45. So for my answer, I'm going to write k composed of h of negative 6 equals 45. So I'm pushing through this part kind of quickly. You can always pause the video, work ahead of me, and check yourself if you want to make sure you have practice doing that sort of arithmetic. Ultimately, you probably should be doing problems 47 and 49 as I do problem 48 and checking your answer to make sure you actually can do it by yourself. 50 pulls out new functions, calls them s and t, but there's no difference in problem 50 than the last problems other than the function names are different. But the idea is going to be the same. To find s minus t of 4, I'll find s minus t of x. To do s minus t of x, I'm going to put a minus sign between two parentheses. The first parentheses, I put the s function, which is x squared plus 5x minus 3. In the right parentheses, I put the t function, which is 2x minus 7. Don't have to simplify that because I'm allowed to plug 4 in. And I can simplify with the 4, which is a lot easier than simplifying with the x. So the structure is the same. I pretended the problem had an x, changed the x to the number that I'm allowed to change it to, and now I'm going to simplify. In the first parentheses, I have a 4 squared, which I'll write as 16. A 5 times 4, which I'll write a plus 20. In the second parentheses, I have a 2 times 4, which I'll write as an 8. So this simplifies to be, the first parentheses comes out to be 33. The second parentheses comes out to be 1, so I'm left with 33 minus 1. The answer to this is going to be 32. And again, I'm writing the problem with the answer, but if you only wrote the number 32, it's completely fine. (52) Compositions are a little bit messier. To do s composed with t of 4, I need to know what s composed with t of x is. To do s composed with t of x, I write the s function without the x's. I leave a parentheses where the x was. So I'm writing that s, which is x squared plus 5x minus 3. I write it without the s, the x's. Write parentheses where the x was. Inside the parentheses, I write the right side of the t function, which is 2x minus 7. I don't need to simplify that because I'm allowed to plug 4 in for the x's. And it's a lot easier to simplify with the 4 than it is the x. So I've changed the x's to 4, and I simplify. First parentheses, I get 2 times 4, which is 8, and then the minus 7. Second parentheses, I also have the 2 plus times 4, which is 8. 8 minus 7 is 1 squared. Each parentheses comes out to be a 1, so I get 1 squared plus 5 times 1 minus 3. This is going to be 1 plus 5 minus 3, that's 3. So for my answer, I'm going to write s composed with t of 4 equals to 3. How many more? 2 more problems till we get to the stuff that is bordering calculus. 54 wants me to do s composed with t of 3. I need to know s composed with t of x, which I just did, but I'll do again because I need it again. To do s composed with t of x, I write the s function without its x's. I leave a parentheses where the x's were. Inside the parentheses, I write the right side of the t function, which is 2x minus 7. Don't need to simplify that because I'm allowed to change the x to 3. Now I'm going to simplify inside of the parentheses first. First parentheses, I multiply the 2 and the 3 and get 6. Second parentheses, I multiply the 2 and the 3 and get 6. 6 minus 7 in both parentheses is negative 1. So I get negative 1 quantity squared plus 5 times negative 1 minus 3. Negative 1 squared is positive 1. 5 times negative 1, I'm going to write a negative 5. So I get 1 minus 5 minus 3, and I think that comes out to negative 7. And again, I'm going to write the problem next to the answer and get s composed of t of 3 equals negative 7. Last one in this grouping, it's backwards, t composed with s, which is easier than s composed with t. To do t composed with s, because the t's written first, I start off by writing the right side of the t function without the x. I leave a parentheses where the x was. Inside the parentheses, I put the right side of the s function, which is x squared plus 5x minus 3. Now I'm just going to change the x to 1 and go 2 times 1 squared plus 5 times 1 minus 3 minus 7. Simplify the inside of the parentheses down to a single number. 1 squared is 1 times 1, which is 1. 5 times 1 is 5. So inside the parentheses, I have 2 times 1 plus 5 minus 3. 1 plus 5 is 6. 6 minus 3 is 3. So this comes out to be 2 times 3 minus 7. 2 times 3 is 6. 6 minus 7 is negative 1. So I get t composed with s of 1, and the answer is going to be negative 1. So every single problem up to this problem 56 either were exact problems for my intermediate algebra or essentially the exact problems I gave in an intermediate algebra class. There wasn't really any quote-unquote college algebra in those problems. So hopefully they weren't humbling and they went pretty well. These next problems are potentially humbling. Algebraically, they're not going to be hard, but understanding what I'm doing, it's going to take a few problems, and it might not even seem like I'm solving the problem like it needs to be solved. 58 through 67, the instructions say find the different quotients. That is, find f of x plus h minus f of x over h. And when I was first exposed to that, it probably meant nothing to me, and I probably went through and did all the problems, got them correct, still meant nothing to me, and that's more than likely going to be the case for you. However, you'll see this again if you take brief calculus or regular calculus very early in the semester, and when you see it a second time, it might click. If it clicks the first time, you're amazing, and that's awesome. But if it doesn't, it's okay. You can still do the problems without understanding the what's going on here. So to do this, I need to find three things. So this fraction asks me to find f of x plus h minus f of x over h. What I'm going to do is I'm going to change f of x to 2x plus 6. So I'm going to rewrite this as, in my efforts to find this difference quotient, is I'm going to replace in this formula the f of x in a parentheses because it's in front, next to a minus sign with 2x plus 6. I'm going to leave the letter h. That's the beginnings of what I need to do. I need to get this written without f's. That f was easy enough to get rid of because I know what f of x is, but I don't know what f of x plus h is. So I need to find out what f of x plus h is so that I can get rid of that f in the numerator. And f of x plus h I get by changing the x to x plus h. So f of x plus h is going to be 2 times x plus h plus 6. And to simplify that, I'm going to go 2 times x and 2 times h and get 2x plus 2h plus 6. So to get rid of the f of x plus h, to get rid of that x, I need to change f of x plus h into that. I'll put it in a parentheses, but it's not really necessary to have it in a parentheses. So when I'm asked to find the difference quotient, what I need to do is take the formula that's given and rewrite the numerator so it doesn't have f's. The first f, the f that's written to the minus sign, I can replace it by what the problem is stated. It's told me that f of x is equal to 2x plus 6, so I was able to change the first f in the numerator, or the second f in the numerator, to 2x plus 6. The first f in the numerator I want to get rid of, and in order to know what f of x plus h is, I need to change the x to x plus h. Now I can write the entire numerator without f's, and this is my goal, to get the numerator written without f's and then to simplify. So this is just repeating what I had written, so I have more room to do my work. This is problem 58, finding the difference quotient. The parentheses I have in the numerator can be gotten rid of. The first parentheses, when I can get rid of it by just dropping it. The second parentheses, it needs to attach to the 2x and make a minus 2x. It needs to change the sign on the 6 to negative. Now I'm going to combine like terms in the numerator. Very specifically, I'm going to take this 2x and that minus 2x, and those will cancel. And this 6 and that minus 6 are also going to cancel. These difference quotients, things without the x's, generally cancel. So when I simplify the numerator, the 2x's and the 6's cancel. The 2h tags along. The h in the denominator, which I haven't done anything with, still stays there. And now I'm going to cancel. The answer to problem 58, this f of x plus h minus f of x over h is equal to 2. The whole answer to this problem is just the number 2, the difference quotient. What I get when I do the operation is just the number 2. If you've ever taken calculus, this is getting close to something called the derivative. 60 wants me to do the same thing. So what I'm going to do is I'm going to start replacing the f's in the numerator. So this function, the difference quotient, f of x plus h minus f of x over h, can be got by getting rid of the f's in the numerator. The easy f in the numerator to get rid of is the f of x because it's 5x plus 4. The f of x plus h, I don't know what to get rid of, how to change it, but I can figure out how to get rid of that f by going to the function and figuring out what f of x plus h is. F of x plus h is going to be 5 times x plus h plus 4. And if I clear the parentheses by going 5 times x and 5 times h, f of x plus h can be written without the x by writing it 5x plus 5h plus 4. So my goal in each of the bottom problems is to get rid of the f's in the numerator. The f to the right of the minus sign, I already know what it equals to. The f to the left of the minus sign, I have to do algebra to figure out what it's equal to. And then once I write the numerator without the f's, I'm going to combine like terms by dropping the parentheses. The first parentheses wasn't really necessary. I can drop it without doing any changing. Second parentheses, the signs change, and now I'm going to combine like terms. Usually the pieces without the x's cancel, without the h's cancel. That's the case in the numerator. 5x and the 5x have opposite signs, they cancel. The 4's also cancel. So when I combine like terms in the numerator, the only thing that doesn't cancel is the 5h. I'm left with 5h over h. The h's cancel, and the answer to problem 6 is just the number 5. I can write this whole function thing next to the answer, or just write the answer, and I'm just going to write 5 just to save space. Okay, keep going here. So this is not supposed to be easy. If it's easy, then you're doing wonderfully. If it's not easy, then you're more like me when I learned this. First thing I'm going to do is I'm going to take this, what I'm asked to find, and write the numerator without the f's. The minus sign between the f's isn't going to go away. The f of x can be written as x squared minus 5. And the h in the denominator doesn't have an f. It's okay. I need to figure out what f of x plus h needs to be changed to. And f of x plus h can be changed to x plus h squared minus 5. That's just changing that x to an x plus h. I'm going to simplify this. X plus h squared is x plus h times x plus h. Squaring means to multiply by itself. That's a foiling. The foiling is x times x for the firsts, x times h for the outers, h times x for the inners, h times h for the lasts. So the foiling part of the f of x plus h gives me x squared. This piece I'm going to write as xh. I'm going to write a 1 in front of it, because if there's no numbers, implied 1. For the hx, I'm going to write that as an xh. They're both plus, so I'm going to put a plus sign. And instead of just writing xh, I'm going to emphasize there's a 1 in front. And the double h at the end, I'm going to write as h squared. These two pieces I'm going to write as 2xh. So in the numerator to the left of the minus sign, to get rid of that f, I'm going to change it to x squared. 1xh and 1xh is going to be 2xh, so plus 2xh plus h squared, not giving myself room, minus 5, because this comes out to be x squared plus 2xh plus h squared. I still have that minus 5. So inside the f of x plus h parentheses, I wrote those 4 pieces, and now I'm just going to simplify. The first parentheses that I put in really weren't necessary, and I can just drop them. And then in the next parentheses, the minus sign is going to cause some signs to change. It's going to give me a minus x squared and a plus 5. Just like in the last 2 problems, this x squared has a minus x squared to cancel it out. This minus 5 has a plus 5 to cancel it out. So when I simplify the numerator by combining like terms, what I have is 2xh plus h squared over h. Numerator is a square, so I can factor. I'm going to factor out a common factor of h in the numerator. When I factor out an h in the numerator, to the left of the plus sign, I'm still left with the 2x. To the right of the plus sign, I had 2h's. I factored out 1. I'm left with 1. After I factor, the h in the denominator will cancel with the h that I factored out in the numerator, and my answer is no longer a fraction because I've canceled out the entire denominator. It's what's left in the parentheses in the numerator without the parentheses anymore when I do the canceling of the h's. It's 2x plus h. All right, I got to be running out of time, but I want to do a couple more problems, and I have 2 more problems to do. And they're messy problems, so I'm going to give myself extra room. So to do 64, I want to change the f of x plus h and the f of x to something. Gave myself a lot of room to do the f of x plus h. To do f of x plus h, it's going to be x plus h squared plus 3 times x plus h plus 5. So the hard part of all these problems is to know how to replace the numerator. I'm replacing the f of x plus h is the hard part. X plus h quantity squared is x plus h times x plus h, which I FOIL. So to find out what to replace the f of x plus h with in the numerator, I'm doing some side work. I'm going to get x squared plus 1xh plus 1xh plus h squared for that part. For this part right here, I'm going to go 3 times x and 3 times h and get plus 3x plus 3h. I'm going to bring down this plus 5. So f of x plus h, if I combine all the like terms, I'm going to get x squared plus 2xh plus h squared plus 3x plus 3h plus 5. This is what I'm going to put in place of that f of x plus h. I'm going to do that now. So to find what I'm asked for here, f of x plus h minus f of x over h, I need to get rid of the f's in the numerator. The first f in the numerator, I'm going to get rid of by, I don't really need a parentheses, but I'll put it in a parentheses. I'm going to go x squared plus 2xh plus h squared plus 3x plus 3h plus 5, and then a minus sign. And then after the minus sign, I need to get rid of the f of x. Well, the f of x can be replaced with x squared plus 3x plus 5. The denominator doesn't have any f's to get rid of, so I'm not worried about it. I'm just going to leave it at h. Leave myself a lot of room now. The first parentheses I wrote in the numerator, x squared plus 2xh plus h squared plus 3x plus 3h plus 5 can just be written as such without any modification. The minus sign is going to attach to each of the terms in the second parentheses, and I'll get minus x squared minus 3x minus 5. Now I'm going to combine like terms. The pieces without the x's should cancel. This x squared, that minus x squared, they cancel. This 3x, this minus 3x, they cancel. This plus 5, that minus 5, they cancel. So after I cancel the terms that can be canceled in the numerator, I get 2xh plus h squared plus 3h over h. Just like in the last problem, the numerator has a common factor of h that I could factor out. When I factor out the h, I'm left with 2x plus h plus 3. That sets me up to cancel the h's. The answer to this problem is no longer a fraction because I've canceled the entire denominator. The answer to what the difference quotient is here is 2x plus h plus 3. Very close to the derivative in calculus. If you took calculus before, you'd put 0 in for that h and have something called the derivative. All right, last problem, 66. Same deal. It's a mess. It wants me to find the difference quotient. And the f of x plus h is the hard thing to figure out. So I'm going to figure out how to change the f of x plus h in the numerator with side work. To change the f of x plus h in the numerator, I go x plus h squared minus 2 times x plus h plus 4. Mess to do this. x plus h squared requires foiling, because that's x plus h times x plus h. So the foiling gives me an x squared for the firsts, a 1xh for the outers, a 1xh for the inners, and h squared for the last. That's all this x plus h quantity squared is. For this piece right here, minus 2 times x plus h, I go minus 2 times x and get minus 2x, minus 2 times h and get a minus 2h, and then I have the plus 4. So this whole line right here, I'm going to change with that f of x plus h. I'm not going to put it in a parentheses this time because it's really not necessary. So to do f of x plus h minus f of x over h, after the minus sign, I get a parentheses and x squared minus 2x plus 4. Before the minus sign, which I really don't need a parentheses, I need this whole horrible thing, this x squared. I can combine these at least to 2xh plus 2xh plus h squared minus 2x minus 2h plus 4. So that's how I get rid of the f's in the numerator. The denominator doesn't have an f, so I don't have to worry about getting rid of it. Now I'm going to write this, give myself a lot of room. The f of x plus h, for the time being, I'm going to write just how it was written. The minus sign that I put in front of this parentheses is going to change the signs. It's going to make the x squared go minus, the minus 2x go plus, and the 4 go minus. And every term that doesn't have an h should cancel. If it doesn't, I've made a mistake. So I see a positive and a negative x squared, which are going to cancel. A minus 2x and a positive 2x, which are going to cancel. A positive 4 and a minus 4, which are going to cancel. Forgot to write this is supposed to be 2h right here. When I wrote this down, that's supposed to be minus 2h. So what hasn't canceled in the numerator, just like all the problems, are the pieces with the h's. I get 2xh plus h squared. That says minus 2h over h. I'm going to factor out an h and get h times 2x plus h minus 2 over h. I'm going to cancel my h's, and my answer to this problem, the difference quotient, is going to be 2x plus h minus 2. Those are tough. The difference quotient problems are really tedious. Really closely bordering on calculus. It's like one step away from being a calculus problem. So they're going to be very important problems to get really good at if you have to take Math 212 or 220 for a future math class, because guaranteed within like the first 2 weeks of the semester you'll be doing different quotients over and over and over again. So getting good at doing those now, when we add the little extra step in calculus that you do to the difference quotient, it'll make that a lot easier for you. All right, so hopefully that wasn't horribly humbling. Hopefully the first part of this felt like a review, because I went through it kind of fast. And then the difference quotient part, hopefully you kind of caught on. If not, feel free, send me an email, come visit me in my office, and I'll try to get you helped out the best I can.